Good luck.
Thank you. So my name is a French test, right? So for my colleague, I say you can call me JFP. I work for IBM on machine learning on the Watson products. But I'm not going to speak for IBM here. But you can call me CPMP. So if people don't know me, that's how I'm known on Kaggle. So you can notice one thing. I'm much better at speaking than doing. Much better. I'm going to give you a few tips that I used to win gold medals. And I try to focus on parts that are often not discussed much. And there are people that are better at me on feature engineering, on parameter optimization. So I want to discuss other topics. First, don't mess with Kaggle rules. I won a gold medal in a competition called Toxic Comment. And that competition turned out to be very toxic for me because I was removed as a cheater. And the reason is I team with Jiba, but that's not the reason why we were removed. And Jiba invited a third guy. And this guy was using 3 accounts, 15 submissions per day since the beginning of the competition. No wonder he had a good ranking when we teamed. So don't do it. Be careful with whom you team with. And also something people don't realize, and I'm reminding them in the forum when they openly discuss about it, you're not supposed to share information outside of teams. For the same reason, the goal is to have a fair competition. And the limit of 5 submissions a day is one way to ensure fairness. And having more than 1 account or acting as a team without teaming is just a way to circumvent this. So don't do it. I don't know how effective Kaggle is about catching the last one, but it's against the spirit of the platform. So I will briefly describe my workflow. Nothing really extraordinary, but I will then focus more on issues not discussed much. So first thing, like everybody, I'm doing some data exploration. But my goal is not to create nice graphics to win votes, which I believe is the case for 99% of the Kaggle kernels on EDA in competitions. They just display the obvious with nice colors. So I'm trying to find interesting insights, even if the graphics is not nice. Like this curve on the left, it's ugly, but it has useful info. So it was in a competition called Talking Data, and it was the target moving average when you look at the data in the right way, and you see clearly something interesting. This is the mean of the target, so it's interesting. On the right, so that was Anthony said leaks is really a problem, because when there is a leak in a competition, it can destroy the value of the competition for the sponsor. So here was a quite famous leak in a competition sponsored by 2 Sigma, where we had to predict the interest of apartment rental ads. And here, with the ads, you had pictures. And there were 3 possible targets, low, middle, high. So I've color-coded, the color is a target, and the 2 dimensions are the time So I don't, maybe it's the hour and the seconds, I don't remember exactly, of the picture file. And you see that the colors are not spread evenly. This is useful EDA. Because if you notice this, then you can exploit the leak. Or if it's not a leak, you can exploit it here. So really, EDA is to try to find predictive patterns. That's the only, for a competition, that's the only interest of doing EDA. So I don't win much votes, but I get insights. Here is another, partial dependency plots were discussed. Here is a variant I use. For a given feature, you have the feature, you have the frequency on the y-axis, and the color is a target. And here you see patterns. You see a surge with a target near 1, and then the target decreases. Then a surge, and it starts again. This is a useful pattern. So try to find ways to look at your data to relate it to the target. I don't understand much plots looking at correlation between features. I don't see the point. Correlation with the target, yes. So after some EDA, I think it's very important to submit. Don't wait too much. Don't build a very sophisticated pipeline before you submit. Just submit to make sure first that you understand the problem correctly, that your code runs, and then you build incrementally. At this, at that, test, submit, and have an incremental approach. Frankly, I'm amazed by people who can win a competition with one submission. This happened in Expedia, I believe. Idle Speculation won with one submission. Now people like Jack from Japan, he uses a handful of submissions. I don't know how he does. He should be a speaker next time. I prefer to have a very sound and scientific approach where you iterate. You have a current state of affairs, of understanding of the problem. You have an hypothesis, maybe this feature, maybe this new model will help. You design an experiment, typically you train a model, and you validate it locally, submit. If the experiment is successful, you progress. If not, try to learn from it. So it's really, the key point here is progressively. Be progressive, don't do, I see people in the last team I was, some good but less experienced people, they test 2 ideas at a time. The problem is, if the result is disappointing, you don't know if one of the ideas would not work. So just test one thing at a time. The most important piece. So after you've succeeded in submitting one model, spend time, and to me this is the most important piece of work, be it in Kaggle or in real life. Make sure you have a way to evaluate your models with your training data that is reliable. If you can't do it, you will just submit and look at the result. It's called LB probing. LB probing can work if the test data is very similar to the private test data and large enough. In any other case, it's just gambling. You could go to casino, you have more chances to win than doing LB probing with too small test data. So for instance, I know not everybody agrees, including in Grandmaster. But what I can say is that my private leaderboard rank is always greater or equal to my public one. Always move up. And I believe it's because of that. I never do LB probing. Sometimes I should, but it's such an evil behavior in real world machine learning that I can't do it here. So I'm not ready to do anything to win at Kaggle. So the right way is to do cross-validation. You have to adjust the number of folds depending on the size of the data and the running times. If you have a time component, you should split by time. So this has been covered many times. If you're not familiar with cross-validation, I think you are if you're on Kaggle, but if not, really spend time. And the goal should be that if your model score on the cross-validation improves, you should see improvement in the leaderboard as well. Not necessarily by the same amount, but they should evolve monotonically. If you achieve this, then you can forget about the leaderboard. You can perform as many experiments you want with your local data, so you're not limited to 5 a day, and you can make progress very quickly. So this is also quite... I think I've not said anything that people don't know so far. Here is something that maybe can surprise people. So that's real number from talking data competition. In the early stage, for me, I had 2 models. So the scores are pretty close, but in that competition, this could mean 100 of positions. I think the winning solution at the end was 0.982, something like that. So I had these 2 models, and when I submitted them, here is what happened. The one that looked better locally was worse. This is a disaster. If this happens, it means you cannot trust your cross-validation. But what I always do is I compute the metric on the training data of each fold, and I take their average here. And we see that the first model score is very high. If you look, so this is ROC curve, if I remember well. So if you look at the error, so the area above the curve instead of below, the first model has only 1% error on training data and 2% on the validation. So it means that the error doubles from training to validation. When the error double, it means the model is overfitting. Whereas this one, the error goes from 1.7% to 2.1. So the error increased only a bit. So it means that the second model generalizes much better. The first one is overfitting. And this shows on the leaderboard score. So what I'm doing when I'm building new models, when I have a new cross-validation score, I want it to be better, but I also look at the training score. And if the training score improves too much, then my model is just overfitting, and probably it won't fare well on the test data. So I always watch the gap between train and validation. And I avoid features that provide a very small cross-validation improvement at the expense of a very large train improvement. So if my base model was model 2 And I am adding a feature to get model 1. Okay, it improves a bit, but it's just overfitting. I would not even submit it. So that's also something I've noticed. I always have, as a result, the gap between validation and leaderboard is smaller. And this is something I observe. I very often have smaller gaps than other competitors. So, feature engineering. For those who don't know this one, there is a great deck on structured data feature engineering. So there are a number of usual techniques. I won't describe them because they have been covered many times. Just one thing. If, like me, you use XGBoost or IBM as a primary algorithm, you should not worry about missing values and one-hot encoding. I'm saying it because I keep seeing people who do it just because these were needed with the previous generation of a general linear model like support vector machines. But when I say there is more than feature engineering, it's because the real useful features, killer features, they don't come from this, never. They come from an understanding of the real problem that we try to solve. Okay, so last part of the workflow is hyperparameter optimization. So far I've discussed structured data, could be deep learning as well. I see especially people who start on Kaggle or they discover XGBoost, they discover that, and they spend all their time tuning all the knobs. Or if they start with deep learning, they will try every architecture that is applicable. This is a waste of time. You should do a bit of it, but my take is this is the best way to overfit. This is very dangerous. So I only do it once, maybe twice in a competition. Once after a couple of weeks when I have something that is reasonable, and maybe once a week before completion. But that's it. There are many reasons for. First, each time you do it, you overfit to your training data. Second, if you do HPO in the middle of the competition, you cannot compare the results you have after with the results you had before. So you don't know if you're making progress. And I don't tune many knobs. The main ones, bagging. So each tree is trained on a subset. Number of, if you use log loss, that's the number of sample in each leaf, minimum. For other loss, it has the same effect. And the depth for XGBoost or the number of leaves for LightGBM. 3 parameters, and they capture most of the value. Sorry. Ensembling. So that's, I would say until 2 years ago, the difference between the Grandmaster and the others were that the Grandmasters were mastering stacking. So they were good at, they still are, good at training a variety of models and assembling them into monster ensembles. So if you look at solutions from 2-year-old competitions, they don't fit on a screen. You had 4 levels and this and that, crazy monster ensembles. This is changing. I'm convinced, and I'm not the only one, Best Fitting was writing the same in Talking Data Competition, that a great model is better than an ensemble. And really, and in talking data competition, I had a single model, 48 features, like GBM, and it was better than ensemble built by teams of dozens of people, including several grandmasters. I was lucky to find this model, but I really believe it's better to spend a lot of time finding a great model, and then in the remaining few weeks, you train other algorithms on the data set that yield this great model. Okay, so far, I think, maybe except for the train validation gap, not sure you've learned much. But now I want to discuss something that I feel is more interesting. That's what interests me in competitions, is to understand the problem to be solved. That's why I'm not so fan of deep learning, because in deep learning, it learns by it's way more automated. You do less feature engineering and data preparation in deep learning than you would do with other algorithms. But here are a few examples. So in the 2 Sigma apartment rental competition, we had to predict from a description of apartments. So you had a text, you had location, number of rooms, etc. You had pictures and a price, a weekly price. And you had to predict if the ad would generate high, medium, or low interest. So we were given a number of ads in 3 classes, and we were asked to build a model. This is a very interesting competition if you like feature engineering. You should just do it, even if it's a past one, because you have a lot of possibilities between geography, between natural language processing, between image processing. Well, there was a leak I mentioned, but if you know there is a leak, then it level set. But I did something very simple. Myself, when I look at ads, how do I decide that one is interesting or not? How would you do it? I think an ad is interesting if the proposed price is below the market. Simple. And conversely, if the price is high compared to the market, it's not interesting. So I decided to train a model to capture the market price. So I took the description of all ads, including the ones in the test data, and I tried to predict their price from their description. And this is interesting because I can use all data, not just the trained data. I use also the test data, and this is not a problem. The better this model, the better. And then I added, as a feature, the difference between the proposed price and the price my model predicts. If the difference is negative, it means the apartment is below market value. And this was my killer feature in that competition. So, and it's not a complex feature. It's just looking at the problem. Another thing I did, I did not have time to put in a slide. So this is for New York City, and mostly Manhattan. So for those who know, streets in Manhattan are in square angles. And given I'm using decision trees, XGBoost at that time, XGBoost splits data. If you plot 2 features, it will plot at right angles. So location is very important here. An apartment can be worth a lot more one side of a street than the other side. So I computed a location in a new coordinate system aligned with the streets of New York, streets and avenues. And then XGBoost was splitting the data by streets and avenues. It gave me a boost as well. Talking data, so that's the competition I'm the most proud of. And it was quite of a challenge. So we were given 350 million click data. And for each click, we had an IP, an application that was clicked on, and then some information about the device, a phone, or it could be a PC, a Mac, whatever. So there was a device type, an operating system type, and a channel. So the goal, we were given clicks on ads on various channels, be them websites or app stores or what have you. But we only had numbers. We don't know what those were. And we had a click time. And then Talking Data, which is a telecom company in China, when there is an application that is downloaded, it assigns it to a previous click. And that's the is attributed, sorry. Yes, that's the is attributed data. That's the target. So you could think that a combination of app, of device and OS and IP uniquely defines a device. It's not the case. IP is shared much more in China than in Western countries. But anyway, this is almost equivalent. An IP, a device, and an OS defines more or less a device. So what features can you do here? It looks like a bit of a limit. But again, if you think about it, if I'm interested by an application on my smartphone, I will click once, twice on ads for it. But when I downloaded it, I will stop clicking on ads. So the problem was actually to detect when people stop clicking. And given you have timestamps, the killer feature was to compute the time to the next click for the same combination of IP, device, OS channel. And that's a killer feature. That's what solves the competition. Time to next click. And you can find it just by thinking a bit yourself, how would you behave? It's like for the apartments. What makes you click or not click? So always try to think, this is about a business problem. How would I behave if I was a Talking Data customer? How would I behave? I will come back to this competition for a second piece. Then, so I say understand the business problem. On Kaggle recently, well, not recently, but more often recently, we find research competitions that are about a scientific problem rather than a business problem. So this one was the last one I did. We were given time series coming from a simulated telescope, and we had to identify for each time series, is it a supernova, is it this, is it that? I'm not an astronomer. But what was very interesting is that there were more class in test data than in training data. That's very challenging. And I wish there were more competition like this, open classification on Kaggle, because I believe this captures a lot of real use case, be it anomaly detection or, in security, in many applications, you don't know in advance everything you can find. And being able to detect that something is new is interesting. So That was the case here. So just, I say I don't like creating nice graphics, but I learned a technique called Gaussian process modeling, and I published a picture, and people said they liked it, so I'm showing it to you. If you don't like it, that's fine, but Gaussian process modeling is very interesting. And I've put my code on GitHub if you're interested. But this shows the data we were given. So each color is a time series for one light source, and they are time-stamped in days. And you see they are missing piece. And basically, depending on the shape of the peak, it is one source or another one. So trying to find an idea of the missing part was very important. So what did I learn here? So it's not about the underlying business problem, but the underlying scientific laws. So in the most common model of the universe is the same in all directions and at all distance. There is no reason to have something more common at a given distance than at another distance. And for light sources, the way to measure distance is called Redshift. So I will not explain what it is. Just Google it if you want. But there is a feature that can be computed from the time series, and they were giving it to us, called the Redshift. So given it's an important piece, I just plot a distribution for each class along Redshift. And that's what you have on the right. So that's on the trained data where I have the class information. So the blue curve is a total number of sources. And the orange piece is a distribution, the frequency for each class along the Redshift. And we see that most are similar, a lot of sample with small Redshift, and then another cluster at large Redshift, except two, the bottom one and this one. And as a result, Redshift alone is able to classify those two classes from the other ones pretty accurately. Well, this is just not right, knowing a bit of physics. This is a bias in the sampling. So the ability, it's very important to detect whether you're on a Kaggle competition or in real world if you have a bias in your training data. If you have bias in your training data that you don't detect, then you find that huskies are wolves, we've seen this morning, or that Afro-American are gorillas. This is a true story, unfortunately. So you have to be careful to avoid bias, and if there is bias, to cope with it. So here there is a bias along the Redshift. So what I did, I just removed this feature. It was the most important feature according to LogicAI. So removing the most important feature, maybe people don't think of it easily. In talking data, I did the same. My most important feature was a channel, and I removed it, and it improved the quality of the model. So beware, don't rely on feature importance blindly. So I removed it. It improved, the cross-validation was not improved, but the leaderboard was improved tremendously. The team in front of us, they used Redshift to weight samples. So samples with a very frequent Redshift. So the weight was the inverse of the blue curve. This addresses some of the problem. But the best one, who finished second, you can use physics law to process the data to undo Redshift. So to normalize in a way along Redshift. And this guy, Mike Kim, did it, and he passed us like a fast train when I'm on a bicycle. It was hard to see, but he did the right thing. So we had 3 different responses. Mine was simple, too simple. But so look for bias in the train. And the current competition I'm in, Microsoft Malware, train is bias versus test. It's a nightmare. So everybody is doing this kind of analysis and trying to understand what to do. Learn from deep learning. So I'm not discussing much deep learning, first because there are people that are way better than me on Kaggle. Second, that in my job, I never meet people that have image problem. Some have natural language problems, but it's a specific use of deep learning, word embeddings, and RNNs. So, but there are many, I must recognize that there are many great ideas in deep learning, and some are applicable in other domains. Data augmentation. You cannot build a good image classification or object localization model if you don't do data augmentation at training time. Why don't we do the same with LightGBM or XGBoost? And I did it in plastic, and all the top 5 teams did some form of data augmentation. I think we should do more of it. And the other use of deep learning that I find very interesting on structured data is to use them for what deep learning is good for. Deep learning is good at learning representation. It's called representation learning. And a great example was given by Michael Yarrer, who won in Porto Seguro. If you've not read his write-up, just do it. It's a wake-up call. And I did something a bit similar in talking data, where I implemented in Keras some factorization metric machine to predict the frequency of co-occurrence of features. And this captured the interaction of features effectively. I will conclude soon with one topic, which is target engineering. We speak about feature engineering, but target should be engineered. So something people do now easily is to change the target so that a custom metric becomes a classical metric. So this is taken from a Kaggle competition. It looks a bit complex. You have a weight of squares of log of blah blah. Y hat. But if you replace y hat by log of y hat plus 1, this is weighted RMSE. And this is handled natively by XGBoost or LightGBM, for instance. So just transform the target into a new one, and you use a built-in metric. Another example in a web traffic prediction competition, that was a metric which is asymmetrical. So that's the target value, and that's the cost of the prediction if it is not the target. So you see it penalizes low prediction more than high. Well, again, if you take a log transform of the target, you get a curve that is very close to mean average error. So that's what I did in the competition. Everybody was implementing custom metric, and I transformed the target instead. And I will finish on this one, I believe. That's again talking data. We noticed, several people, that for the same features, you can have a repeated rows with different target. It means that clicks were too close in time. They were within 1 second. Well, if you remember what I said, the click before the download should be the last click. So what I did is I sorted in the training data and in the test data the data so that data having the same timestamp, everything was sorted by the target. So that the downloads, the target 1 was always after the target 0 if everything was the same elsewhere. This improved my score, and I jumped like 10 ranks. So here I changed the target. It was a bet because here I had to submit to see if it was working. But so it happened that, in fact, when the data was prepared, the test data was sorted, as I said, but not the trained data. So this is my conclusion. Don't spend time tuning knobs or trying all neural net architectures you can find. Think about what is the problem to be solved. If it's about end customers, as a customer, how would you behave? If it's a scientific domain, try to understand a bit the basics of that domain. Also look at how models are evaluated in the competition or in real life. You need a metric also in real life. And then act accordingly. I see people evaluating feature engineering by accuracy or information value or correlation instead of training a model and using the competition metric. You should evaluate according to what matters. So act accordingly and then have fun. I don't know for you, but my wife has to stop me regularly on this is, I say that Kaggle is a legal drug. It's better than gambling because you learn something. I'm open for question if we have time.
Yep. Thank you, Jean-François. We don't, unfortunately, we don't have that much time, but I think we'll still like try to find 2 questions, 2 quick answers. So, any questions? In the audience? Okay. What about you?
So it's a quick one. Do you have any strategy when you are creating teams?
I'm not good at teaming, as I explained. I got burned.
You are very good. I've seen it.
So far, I always team because people contacted me. So my strategy is to learn how to say, when to say yes or no, basically. And you know, even teaming with Jiba is not always a perfect choice, given in one case, no, I'm kidding. He's great to team with. I don't want to be on a large team, and you've seen Kaggle is reducing the limit. I think it's good because the time you spend in coordination. But I have good experience when I teamed. Last time it was with 2 people from Singapore, different culture, different. That's good because sometimes it's a bit hard, time delay, but best is when you team with people that think differently from you. It's like blending models, as was said several times. The more diverse, the better the result. And my first team, where is Yifan? It was great. So a Chinese working in UK, an Indian working in India, a Chinese in China, and me. Very diverse. It was a crazy one, but it was a good one. Maybe another one, or?
Okay, any other questions? Any last one? Okay, if not...
there is one.
Okay, but fast, please.
Thank you for being here. And so is the way you, I guess, how do I say this? Your workflow based on like the reason that you don't trust neural networks so much is because you just learned them.
I'd say don't discuss much neural networks because I have more to learn from you than the reverse. I enter regularly, and I hope I'm progressing. The other one is in my job at IBM. Our custom applications, they are mostly about structured data or natural text, natural language. We don't see much image. That's all. But for natural language, I will use word embeddings, I will use RNNs.
And I just meant, like, since you learned, I think you learned neural networks within the last year or something. You were talking about how you learned that. I mean, this is from a previous conversation, but.
I started, first time I did deep learning was in the web traffic. I was plafoning in XGBoost, and in the last 2 weeks, I started with Keras. So it's recent, yes.
Thank you.